So continuing here, as I was telling that if you place your crystal here, you will find the upper face here, not 1. This is the equatorial projection or stereographic projection in case of crystallography, right? So you will find not 1 here. This is the front face, 1 not. This is the back face, 1 bar not. The right side positive B or positive A2, not 1 not 1 bar not. And here you are getting those dodecahedron faces, vertical dodecahedron faces. Like if this is the let's say this is cube, okay, so this face means it is cutting A1 and A2, it is cutting A1 and A2, so this will be 1 1 not, okay. So this will be backside of A1, that means negative A1 positive A2, so 1 bar 1 not. Now this face will be, if I'll take this face, this is negative A1 negative A2. For you people this is negative A2, so this is 1 bar not. Now this will become positive A1 negative A2, so 1 bar not. So I am writing here 1 1 not, 1 bar 1 not, 1 bar not, and 1 bar not, okay. Then if you take planes here, if you take a plane here, so this will be, if we take these planes means these are, you can say this is cutting what? A1 axis and C axis, not the A2 axis. This plane is cutting A1 axis and C axis. Like if I'll take this plane, if I take this plane, I will make a perpendicular, I will join that with the nadir, okay. This is the plane, this is the crystal, I have placed it within the sphere. This is the plane, I join this plane, I made a perpendicular to this plane, it will form a spherical projection here, somewhat here, I will join that point with the nadir, so I will get intersection somewhat here. So this plane is having what? This plane is having symbol cutting A1 axis, cutting C axis or A3 axis, not A2. So here you will get symbol 1 not 1. This is also same, this is also guided, this dodecahedron face, this is also dodecahedron face. Now this is this face. This face means it is cutting A2, it is cutting C. This is the face. I will make a perpendicular here, it will join the spherical projection here. I will join it with the nadir, it will cut the equatorial plane here. So this is not 1 1. Now it will become, similarly it is the backside face here, this face. This is 1 bar not 1. Now here this is this side face, right side face, okay, or this will be not 1 bar 1, okay. You will not get 1 bar in C, you will not get 1 bar in C, because we are not taking the lower hemisphere, we are not taking the lower hemisphere, that's why you will not get negative C axis or negative A3 axis, okay. Then if you take this face, if you take the octahedron faces, octahedron means cutting A1, A2 and A3. So it will be triangular face cutting A1, A2 and A3. So this is 1 1 1. This face will be 1 1 1. I will join, I will make a perpendicular, it will touch the sphere here, then I will made it to join to the nadir. So it will cut the equatorial plane somewhat here. So that will be placed here only. Okay, this is 1 1 1. Now if I place that point here, it will be 1 bar 1 1. This side face. This side means A1 is negative, A2 is positive, C is or A3 is positive. So 1 bar 1 1. Here this point means this corner, this corner. This corner means negative of A1, negative of A2 and positive of C. So 1 bar 1. Now this point will be your positive A1, negative A2, positive C, this face. I will make perpendicular, I will join with the nadir, it will cut here. So here it will be 1 bar 1. Okay, so these are all faces. Now if I will join them, it will be like this. So have you studied this figure? I hope all of you studied in this HM symbol. So this figure actually originated from here. Okay, then you can join these lines also. Okay, so I hope all of you studied this diagram in HM symbol, or else we will discuss in crystallography. So this is the diagram which is derived from this stereographic projection of the crystal. Okay, so in crystallography we are using such kind of projection. It is plotted in a stereo net called what? Equal angle net. Equal angle net. Okay, for crystallography we are using Excel means crystal. Okay, while whenever I write Excel, that means it's crystal. So for crystallography we are using equal angle net, or we name it as equal angle projection. Equal angle projection. Okay, that means in each side you are getting equal angle. Okay, I will show you the stereo net if possible. Okay, so in case of crystallography, or else you can search in net also. Okay, equal angle net is your that is used in your crystallographic projection. It is also known as I forget, I think it's wolf net. It's wolf net. Okay, wolf net is your equal angle net which is used in your crystallography. For structural, yes, I think this is all about your crystallography projection. Then I will move to again structural. Okay, so let me erase this one. So I guess all of you understood this. Now coming to structural, I have already told you, if I made to pass a structural feature, either that will be plane. So if I made to pass a plane here, that will cut the lower hemisphere like this, an arc, then I will join each point on the arc with the northern pole, or that is zenith. Then it will intersect the equatorial plane at some points. It will intersect the equatorial plane at some points. If I will join those points, I will get a arc which I name as great circle. Okay, in structural geology, I am placing now this equatorial plane like this. Okay, so that great circle is like okay, this is my stereo net for structural. I have got this great circle. That great circle is like this. Okay, for this plane it will intersect like this. That is the spherical projection. I have joined all the points on the spherical projection with the northern pole or zenith. That will cut the equatorial plane at some points. So those points, if I will join, I will get this line which is known as your great circle. Okay, so if I pass another plane like this, if I will pass another plane like this, if I pass another plane like this, and the principle is same, I will pass this plane with through the center of the sphere. I will pass this plane through the center of the sphere. So then it will again cut like this arc, and I will join each points on the arc to zenith. Then they will form a great circle here. Then they will form a great circle here, right? If I will join all the points in the arc or in the spherical projection to the zenith, they will make a great circle here like this. I can do another great circle like this. Okay, I can make several grid circles. I can make several grid circles like this. Okay, so these grid circles, each of the grid circle is representing a plane. Okay, as you can see from here that from a single plane I am getting a grid circle. For this plane I am getting another grid circle. Okay, so each grid circle which are represented in this stereo net of what you are using in structural geology, that is known as equal area projection. In crystallography that is equal angle, here it is equal area projection, or the net is known as equal area net. Good. Okay, the net is known as equal area net, or it is known as skimmed net. This is known as skimmed net. Okay, or equal area net. So here you are getting grid circles. Each grid circle will represent a plane like this. If I'll pass a horizontal plane here, let's say I am passing a horizontal plane here. Okay, if I'll pass a horizontal plane here, then the principle is same. I am passing this horizontal plane through the center of the sphere. If I'll pass a horizontal plane through the center of the sphere, it will intersect the sphere at this equatorial plane itself. Right? This is the sphere. I am passing a horizontal plane, and that should be passed through the center. So the intersection becomes a circle, and that is your equatorial circle only. That means this outside circle, it is representing a horizontal plane. Okay, this outside circle, or the perimeter of the net, or the perimeter of the circle which is defining the perimeter of the net. Okay, for the outermost circle, it is your horizontal plane. It is representing a horizontal plane which is passed through the sphere through its center. If I'll pass a vertical plane here, like this, then what it will make? It will make an arc like this. It becomes clumsy, so let me erase that. So this is the sphere, and I am passing a vertical plane like this. Okay. This is the center. Now this is the equatorial circle. This is the equatorial circle. So if I pass this vertical plane here, it will intersect with an arc like this. So it will intersect like this only, right? This is the equatorial equatorial plane, and this is the intersection. Now if I'll join each points, see, this is the center. I am passing the vertical plane here. It will made a arc like this. Now this is my north pole. I am joining this. So in the equatorial plane, it will give us a straight line. I hope all of you understood. This is the sphere, this is the center. I passed the vertical plane through the center. It will make an arc like this. Now if I join these points to the zenith, this is the zenith. Now if I join these points to zenith, okay, like this, you will get what? A line. You will get a straight line here. Instead of circle, instead of arc, instead of arcs, you will get a what? Straight line. Similarly, here you will get one straight line. Here you will get that straight line is represented here. Okay, that means this straight line is representing what? A vertical plane. Like this outermost circle, it is representing what? Horizontal plane. This straight line present on this equatorial net is your vertical plane. Okay, that means horizontal plane means deep amount is 0 degree. Horizontal plane means deep amount is 0 degree. Vertical plane means deep amount is 90 degree. Deep amount is 90 degree. Okay, for horizontal plane you are getting deep amount 0 degree. For vertical plane deep amount is 90 degree. From the outer circle you are getting 0 degree. At the center there is a straight line, you are getting 90 degree. That means what? While you are moving from this outer circle to the center, while you moving in this direction, deep amount is increasing. Okay, you are getting 0 degree at the equatorial plane, at this equatorial circle or this outer circle. You are getting 90 degree deep at the center in the straight line. So from outer circle to the central line, the deep amount is increasing, both in this side and also in this side. This is 0 to 90, this is 0 to 90. This is the increase in deep amount. And these grid circles, okay, these are the grid circles. If these grid circles are joining a point here and a point here, let me make another diagram here. If I'll make another diagram here like this, okay, and this is the grid circle, this is the grid circle. Okay, so this grid circle is representing the inclined plane. It is representing the inclined plane because I have told outside is horizontal. If I will make a straight line, that is vertical. All others are inclined. All others are inclined. These are 3 inclined, these are 3 inclined planes. And you can see this is the plane which is intersecting at a point here, at a point here to the equatorial circle. That means what? This is your horizontal, this is your inclined plane, this is your inclined plane, right? This means these points, just notice here, these are 2 points which are found or which are obtained as intersection of this inclined plane and a horizontal plane. Okay, these are 2 points, which I am obtaining or which I am getting due to the intersection of inclined plane with the horizontal plane. So just remember what is the intersection between an inclined plane and a horizontal plane. That is known as strike. That is known as what? Strike. Strike is nothing but if you get 2 horizontal points on the inclined bed. This is the inclined bed. We are getting 2 horizontal points. If you will join this, you will get a strike line. You will get a strike line. Similarly, if you join these 2 points, this will give you strike line. Okay? This will give you strike line. Now if I mark here it is north and south, that means this bed is inclined having strike north south. And what is the true dip direction? True dip direction means it is 90 degree to strike. It is 90 degree to strike. So you can see the bed is dipping towards right. It is dipping towards right. That means east. If it will be north, it will be south. This will be east. This will be west. Okay. If I am marking here it is north, then it will become south. It will become east. It will become west. That means this is the bed which is having strike north and south. How I get the strike? Because they are intersecting the horizontal plane at those 2 points. Now if I will make a perpendicular to it like this, now if I will make a perpendicular to the strike here, it is going towards east because it is dipping towards right. So inclined towards right, that means I am making this line, and if this angle is 90 degree. This angle is 90 degree. So this plane is having strike along north south and dipping along east at certain amount. At certain amount. How can I know the amount? The amount is given by here. The amount is given by this measurement. The amount is given by this measurement. Okay? As I have shown it here, at the outer circle it is 0. Here you are getting 90 degree. So from 0 to this much gap. Let's say this is this I have divided into four parts. That means this is having some part, this is having some part, this is having some part, having some part, right? So this is having 90 by 4. This much length is 90 by 4, this much length is 90 by 4, this much length is 90 by 4, this much length is 90 by 4. Got that? This total length is 90 degree. This is 0 degree at the outer circle. At the center you are getting 90 degree, and I have done 3 great circles. That means I have made it 4 parts. I have made it 4 parts. So this is 90 by 4 degree. 90 by 4 means that is 22.5 or something. 22.5. Yes, that is 22.5 degree. So this is 22.5 degree, 22.5 degree, 22.5 degree, and 22.5 degree. That means this bed is dipping 22.5 degree towards east. This is dipping how much? 45 degree towards east. This is dipping 45 plus 22.5 means that is 45 plus 22.5, that means 67.5. Then it is 90 degree. I think all of you get this. This total length is 90 degree. I have made only 3 great circles. So this is 90 by 4, this is 90 by 4, this is 90 by 4, this is 90 by 4. So here it is 22.5, here it is 45, here it is 67.5, now it is 90. So each great circle what I made here, it is having a strike along north-south, and this side it is dipping towards east, and this side it is dipping towards west. These great circles are dipping towards west. It is also same 90 by 4, 90 by 4, 90 by 4, 90 by 4. Okay, so it is dipping towards west. These planes are, if I done this and dipping towards east, if I will do a plane like this, that means it is having strike north south and dipping towards west, and the amount is given by this measurement, because it is 0 degree, it is 90 degree. So I am measuring from 0 degree, 10 degree, 20 degree, 30 degree, 40 degree, 50 degree, let's say 60 degree, like that. If I will make a plane here, 70, 80, then 90, like that. Okay, I think all of you got this. Let's say 0 degree, 10 degree, 20 degree, 30 degree, 40 degree, 50 degree, 50, like that. Okay, so in a stereo net you are getting number of great circles like this, okay, which are all striking towards north south, some of them are dipping east, some of them are dipping west, and deep amount is given in there are some bold lines also, there are some bold lines and there are some small lines also. Okay, each bold line will give you 10 degree deep amount. Okay, each bold line you will get 10 degree deep amount. I am talking about stereo net, I am talking about equal area net, I am talking about skimmed net, right? The equal area net which we are using for structural projection, or we do it generally in practicals, we plot it on tracing sheets. Okay, so you are getting this bold line, two bold lines, there will be difference of 10 degree, there will be difference of 10 degree, and each small line they will give you a difference of 2 degree. Okay, like this I have told you na, these are bold lines, I will get 10 degree difference, here it is 0, then 10, then 20, 30, 40, 50, 60, 90. Between two bold lines you are getting small lighter lines also, those are giving you amount difference of 2 degree. Like graph papers, you are also seeing na, like this is a graph paper, you are getting 10 degree like this, and then you are getting smaller lengths. Like similarly you are getting in stereo net, the larger or bold great circles are of difference 10 degree, and the smaller ones they will give you difference of 2 degree. And all these great circles are having strike of north south and dipping east, and either east or west. Either east, this side is dipping east, this side is dipping west. So you can plot planes. I will describe how we are plotting planes on stereo net in the next video. So in this video I am only generalizing these things, how we are getting great circles. Okay, now these are the great circles. Now there are something named as small circles. The great circles are striking along north and south. There are small circles like this. There are small circles like this. Okay, there are small circles like this. How these small circles are obtained? I have told you, these great circles are obtained by passing planes in the in the center, and you will get what? A arc, and you have to join those arcs with the zenith. For these small circles, what you have to do? You have to pass a cone here. You have to pass a cone like this. You have to pass a cone here with its apex at the center of the sphere. Okay, you are passing a cones like this. You are passing cones like this. Okay, you have to pass the cone in the sphere, okay, with its apex at the center. So they will make circles here, they will make circles here. Then while you join these circles with the zenith, while you join these circles with the zenith, you are finding these small circles. You are finding these small circles on the equatorial plane. On the equatorial plane. I hope all of you got this. This is the sphere. I will pass what? I will pass a cone. I will pass a cone means cone's base is circular. So it will intersect the sphere at a circle. If I will join each point on the circle to the zenith, if I will join each point on the circle to the zenith, it will pass through the equatorial plane, making these small circles. These are known as small circles. These are known as small circle. Okay, the great circle are obtained by this intersection of plane to the sphere and then spherical projection to equatorial projection to get stereographic projection. For this small circle you have to pass cones. Okay, they will give you such small circles. So this is your equal area net. For equal angle net we are using that